And you can see that on chapter number 9, the very first page towards the bottom, page 133, that it starts out with go-to statements. Go-to statements are a big no. Don't do them. So go-to statements must be avoided at all cost because they are predating loops. They've been around for a very long time, but over the period of time, nobody uses them. Nobody encourages you to use them. Followed by an if-else, which you already know. All of you should know what is an if-else. And followed by select when, which is like switch case. Okay. Followed by do while, which you know what it is, right? Followed by do until, which you don't know what it is, because you've never seen a do until loop. You have seen do while, you have seen while, and you have seen for. So that's do for. And then we have a call subroutine. It's like creating functions and then calling them, that kind of stuff, passing parameters and stuff like that. So that's basically the focus for this chapter. Anybody has any questions before we move forward? Okay, good. As soon as I share my screen, I have to rearrange all the screens. So chapter 9, page 133. This is what we just looked at. Now, if we turn over to page number 134 in the book, it shows you the different diagrams of the different control structures. Do you guys have any questions about any of these structures or flowcharts? Yep, Aiden, it is a switch case. Yep. What is the difference between do while and do until?
The do while checks the condition and then does the process.
So do until is like do while in Java or C#, where the condition is towards the end of the loop. And do while is like while in Java or C#, where the condition is before you enter the body of the loop. So do while is a precondition loop, and do until is a post-condition loop. Right. Okay. Now, turning to page 135. Welcome, Christian. And we will see the go-to command here. As you can see in the little code snippet, it shows you like this one, right in the middle of page 135. It shows you that you can call go-to command and you can jump to a label. It allows you to jump from one location to another. That's what it does. It can also be used as a loop, like you make a call to another program. You call a command, then you call another program, and then you say, okay, I want to go to loop 1. So this is how you can jump like a loop. So that's what go to statement does. If condition is pretty much like it is in Java or C#, but of course it's a different syntax. So I don't need to explain to you the basic concept of an if condition, but I can explain to you the syntax. Unlike Java and C#, you can see over here that if condition is written with the word then. So you write if, you write a condition. And then after that condition, you write the word then, and the then has parentheses, and the parentheses can only have a single instruction. Does that mean an if condition only allows for a single instruction? No. But when you are writing it in this format, yes. We will look at later on how you can put multiple conditions inside an if. So by default, only one condition is allowed. So either you use the word cond and then, so you use keyword notations, or you can skip the keyword notation and you can simply write your condition like this: if a condition in parentheses and followed by an instruction. So you have both of these choices. And the third choice also is there to show you that within the body of an if condition, you could change the value of the conditional variable. So here we are changing the value of number by decreasing it by 1, and then that's all we are doing here. It is also possible for you to create nested ifs, which is an if within an if. So if the condition, which is user equals to student 1, then if the condition that is number equals to 5, then display the tape number 1 at the output. This could also be written out like this: if a user equals student 1 without the word condition, without the word then, if the number equals to 5, then display tape and the display tape command. So basically, this instruction is inside this if condition, and this if condition is inside that if condition. So there's only one instruction per level. And here is another one. If user is student, if that is true, if number is 5, if that is true, if day is Tuesday, if that is true, then display the tape. So you can have multiple levels of nesting as well. Since it is easier for you to read the if condition in the keyword, in the positional notation, that's why in most cases you will see that developers will write it like this versus that. Now we'll look at the else command. Else is the alternate. If option is 1, go to option 1. If option is 2, go to option 2. Bunch of instructions. If continuous equals to yes, go to loop, right, which is back here. Otherwise, go to end. So that otherwise is like an else. Nested if else. What is that? Well, basically, if you have a multiple conditions, more than 2 conditions, then you can use else ifs. So if user is student 1, then let's check to see, maybe the number is 5. If number is not 5, then let's check to see if day is Tuesday, right? Otherwise, go to next one. Now comes the question that what if I want to include multiple instructions inside an if condition? Well, that's where in CL the do groups come in. If multiple instructions are part of an if condition, you write if followed by a condition, then you write the word do. Then you pack all the instructions that you need to pack, and then you close it out with and do. So between do and end do, all these instructions are part of if. So do and end do work pretty much like opening and closing curly braces. That's pretty much how the do and do works. Now, what I would like you guys to do is I want you to read pages 136 through 139. And let me know if you have any questions. Christian, I send you some messages in the chat so you can read those and respond to me. Okay, so as you guys are done reading those pages, can you give me a green check so that I know? Once everybody's done, we will then move on to page 140. I'm waiting for Aiden, Victor, Kyle, Devin, Luke, and Christian. Why is that, Aiden? Is it taking you longer? Oh, okay, okay. So are you in the right chapter though, right? So I don't know how far you went, but we have not read about the select case yet. So if you've read about if conditions, then that's how far I wanted everybody to read. Oh my God. Oh, oh, wow. Okay, so you're all set for several reads that we will be doing today. My goodness. Okay, how about Devin? Devin, are you still reading? I don't know if Devin is there or not. Anyway, we will move on to slide number 9, which is select when otherwise. This is like a switch case, as I told you guys, that may simplify, it will help you simplify your nested if conditions. And you can look at the keywords that are used in a select case. We use the word select, and we ended with the word and select. We use the word when for each and every condition, and we use the word otherwise for the very last condition. If you guys remember your switch cases in Java, let me grab one example, which is very similar to the way it is in C#. So even if you haven't had a chance of learning Java yet, you can understand because you know C#. All of you know C#. So that's why you should be able to understand this code. So we have switch, and we take a variable in parentheses. That's in Java or C#. Then we put curly braces. We don't do any of that stuff over here in CL. In Java and C#, we put case. Each case has its own condition, and all cases are tied to a single variable. And the last case is called default. The default case is called otherwise here. Now, let me take you to an example in CL. Here's an example. Okay, now let's bring both languages next to each other. Look at the very first example. In CL, do you see the variable name next to the select? And your answer will be no, which is the first difference that you see between switch case and select. Switch is tied to a variable. Select is not tied to a single variable. Okay, select is tied to conditions. Switch case is tied to variable value condition. Now each when has its own condition, which is unlike Java, because in Java, all the conditions work on equality, means is input equals to Java, or is input equals to Python, or is the input equals to Rust, and so on and so forth. But here, each condition is a separate condition, and this is where you can use a variable, any of the conditional operators, and a value. That means when the sales is less than equals to 5,000, do nothing. When the sales is less than equals to 10,000, call this program. When it is less than equals to 20,000, call this program, otherwise call this program. Now, if you are checking for the value 9,000, the first condition will fail. So you're automatically at the second condition. That's how it will work. Okay, now let's look at this. Here we have a select case where in the when, the very first when, it says the variable is less than 0, do nothing. And if the variable is equals to 0, now I have multiple instructions. Since I have multiple instructions, I will again use do and do. Do and do, which is different from Java, because in Java you can list multiple instructions and you can close it out with a break. We don't have break here. No condition is separated by a break. So every condition is tied to a single instruction only, and that single instruction, as soon as it is done, will jump to end select. If you want multiple instructions to run, then you can do do, and you can write all the instructions there. And when it hits end do, that's when it jumps to end select. Does that make sense to you guys? Is everybody following that?
Yeah.
Okay. I just wanted to make sure, bringing in Java is not confusing you guys more. That's why I brought in another language that or C#, because some of you are not taking Java this semester, but will take it in summer. So just wanted to make sure if you all understood this. Okay, so now go ahead, for those of you who haven't read page 140, go ahead and read page 140. And that will be everybody but Aiden, right? And again, give me a green check when you are done reading.
So we don't have to put break because it ends as soon as one of the conditions are met.
Yep, so as soon as the condition is met, it only runs one instruction that is associated with the condition. As soon as it runs that instruction, it jumps to end select. If there are more than one instructions in a condition, then you will do a do and do block. And as soon as it hits the end of the end do block, it ends and terminates the select.
That second one I don't understand. So it's like if that condition is met and then the condition after it is also met.
No, it never checks any condition after the one that is met.
Okay. Got it.
So as soon as the condition is met, it will run the instructions associated with the condition and will then jump to end select.
Oh, okay. So do is telling the program what it should do if that condition is met.
Well, no. Do and do is there because there are more than one instructions that will run for a condition. You do not need the do and do block if there's only one instruction associated with the condition being true.
Okay. So
Okay.
if there's more than one instruction, it requires a do and
Do
then
and do, yep. And that's the same case in the if condition. That's the same case in select.
Got it.
And that'll be the same case in loops. Anywhere you have to have multiple instructions with a condition, you have to use do and do block because we don't have curly braces in CL.
Okay. Got it. Thank you.
Mhm. So we still have a few people reading. Oscar, Jacob, yeah, okay. Devin, I don't know if he's back. Now we'll be moving down onto loops. You guys already know what is a loop. The loop is something that keeps going till the condition is met. And conditional loop repeats a code group based upon a condition. So they are do while and the do until. Those are the two categories of loops. And these are called the conditional loops. And when it comes to count controlled, we only have one loop, that is the do for loop. Now the do while loop, let me bring in an equivalent Java code here. 1 second. Here we go. Here you go. Okay. There's an equivalent Java code that you can see. So here we start with the word do while in CL. In Java, we start with the word while. It's same in C#. In Java or C#, you write a condition after that. And also here, you write a condition after that. In this case, the condition is a Boolean variable in this example in the book. Then you have an instruction inside the do while. Then you have an if condition. The if condition says if the integer is greater than 100, then I want to change the variable flag to a 0. And then it ends do. That means go back and check the condition again. If flag is still true, it will go back in the loop and will increment the value integer by 1. I'll keep doing it till the condition reaches true, which is if the value of integer exceeds 100, then it will turn the flag to false, so the loop will terminate. So loop runs all the way till it reaches 100. Very similar to this one, but the only difference is that here we are not using flags. Here we are using a flag. Okay. Now read the do while on page 141, and then I will move on to page 142. Okay. We will now look at do until. Do until is slightly different from do while. In do while, the loops keep looping until the condition becomes false, right? Until the condition becomes false. So that's why we are starting the flag from true in do while. But when it comes to do until, notice the condition starts with false. So the loop keeps looping as long as the condition is false. It terminates when the condition becomes true. It's the reverse logic loop. It's pretty much like keep cleaning while the dad is away. Keep cleaning while dad is not home until the dad comes back home. So it's basically works just the opposite. It's the same condition, just works the other way around. So here is an example from the IBM website. You can see, unlike the one in the book, we are using a condition here of a variable integer greater than 100. So you can also use variables to do this. A group of commands between do until and end do will be processed until the value of integer is greater than 100. When the end do command is processed, the contents of do until group will be processed at least once. That means that since it checks, even though you write the condition at the beginning, it still checks the condition in the end. So that's why you will at least go through the body of the loop at least once. Okay, for loop. Let me share this link of do until with you guys in the chat, so you guys can also go over this, and then we will go on to the for loop. Subroutines are like methods, Aiden, to answer your question. Okay, next comes the do for. In Java, you start the loop with initializing a variable to a value. Then you check to see if the variable has not reached that value, you keep looping. So you're starting I at 5, you want to go to 10, and you want to increment by 1. So it is 5 the first time, then 6, then 7, then 8, then 9, then 10. So it runs 6 times. 7th time, when I becomes 11, it terminates. Now here, on the other hand, we do not need an increment. It auto increments by 1. So you start with the word do for, and you write the name of the variable. to which you want to increment, that you want to increment, and you put the starting point, you put the ending point, and then it goes from 1 all the way through 100, incrementing by 1. I am sharing with you a link in the chat, which is the help link for the do for loop on the IBM's website. Now, this is where it tells you that when you are declaring a variable, let's say there's a variable called int, setting to the length of 2, and you want that variable to go from 1 through 10, it's exactly like the one in the book. However, if you want that variable to go or increment more than by 1 or decrement by more than by 1, then you can use a by clause in the same line where you have your do for, you write the variable name from to. You can write by, and in the by you can use a value, so that value will allow you to go up and down depending on the value that you put. And the explanation of all of these is given to you on this page. So go ahead, you can go over this page and also go over pages 142 and 143 in the book. Okay. Next, we will look at iterate and leave. What iterate and leave do is that iterate allows you to keep looping in the loop. And if you want to ever skip a particular occurrence of a loop, you can write it in a condition that if this particular occurrence happens, Then skip the rest of the code and go to the next iteration of the loop. In Java and C#, the equivalent is continue. And if you want your loop to terminate before it reaches the end condition, so instead of saying, I mean, like break, as we have in Java or C#, we use the word leave. So for example, I have a loop. It doesn't matter you're using for loop or do while or do until, doesn't matter. Inside the loop, you're saying if the value reaches 2, then iterate. That means this line will be skipped and iterate will going to go to the next cycle. If instead of iterate, I use the word leave, then what will happen is the loop will only run for 2 times. One time for 1, the next time for 2, and the leave will throw you towards the end of the loop. So that's basically, you know, in syntax, that's what basically it does. Leave allows you an early exit, and iterate allows you to skip. Now in the book, you do have some examples as well. For example, right here, this example is on page number 144, that if the mod variable equals ADD, then call the following program and then skip the rest of the code, and that will go back to the next cycle in the code. If instead of iterate, we use the word leave, okay, then what happens is that it simply terminates the loop right there and then. So go ahead and complete page 143, the loop and early exits part, and page 144. Read the remaining half of 143 and page 144. Okay. Now let's move on to page 145, which is about subroutines. As I told you guys earlier, that subroutines are like methods. So subroutine is a named block of code inside a program where you can put your instructions. You can call that subroutine anytime you need to do something. That subroutine will do its job and they're going to terminate, come back to you, whoever the caller is. So there are 4 commands to keep in mind when it comes to subroutines. First of all, we have a command called call subroutine, which is a command that we will use to call a subroutine, provided the subroutine exists. Then we have a command called subroutine, which is right at the beginning of the subroutine, and end subroutine, which is right at the end of the subroutine to create a subroutine block. And then we have the return subroutine, which is pretty much like exit or leave. So if you want to leave a subroutine before it reaches its end, you can use the return subroutine command. So these are the 4 commands that we use, or keywords that we use when creating subroutines. So subroutines are typically created the way the syntax is shown to you at the bottom of page 145, that you write the word sub R space, you write the name of the subroutine and parentheses. The parentheses is where the parameters go. Then you write the entire body of the subroutine and you close it out with the word end subroutine. And if it's a value returning subroutine, then you write the return val. Unlike the functions in Java, where you write the word void, or you replace the word void with a different word for value or non-value returning, you don't write anything like that here. You do not mention anything on the first line, whether the subroutine will return a value or not. It is pretty much defined by the return val's instruction on the very last line. So if you look at page number 146, where you have this example. So let's say if I have a subroutine called cleanup, okay? The cleanup doesn't take any parameter, so we don't use any parentheses. Cleanup doesn't return anything back, so we don't have a return instruction over here either. So we are not returning any value at the end, okay? And then all this does, it deletes the file and it calls pgmlog, a program. That's what the cleanup does. We have another subroutine called no, which calls a program, calls another program, and then checks to see if condition is true or false. Based on that, changes the variable's value, and so on and so forth. Okay. So here you can see in the do while loop that if the answer equals yes, call the subroutine yes. Otherwise, call the subroutine no. So whenever the no is done or the yes is done, the control will come back to inside the loop. And then finally, when the loop ends, it calls cleanup. How does the yes work? Same way as no. No difference between the no and yes other than the code logic. Okay. Then subroutines and the goto instruction comes in. So goto must specify label within subroutine. So for example, if I call my PGM yes, so if restart equals y, this is all part of the subroutine called my sub r. If restart equals y, go to start. So it's going to jump to start. Okay. So cannot branch out of subroutine. Okay. So you cannot use goto to come out of the subroutine to another branch. Nested subroutines are also not allowed. You cannot create a function within a function exactly the same way. You cannot create a subroutine within a subroutine. One subroutine calls subroutine another subroutine. So you can basically make one subroutine call another one. There is one more topic at the bottom of page 147. It is called the declare processing option command, DCL PRCOPT. A CL program keeps track of the number and the memory location of concurrently active subroutines in a list called the subroutine stack. Who knows how stack works in programming? Anybody knows how stack works in programming? In terms of function calls? Apparently nobody knows. Not sure. Okay. How about the rest of you? Okay. Do you understand this code? Let me ask you this. This is Java code. Have a look at it and let me know if you understand this code. Yes, no, you do? Okay. Okay. Now, to make your life a little bit easier, look at this version of the code. In the main method, you run a loop that runs from 0 through whatever is the length of args, doesn't matter. Every time the loop runs, it grabs the value of args, puts it into arg, and then it makes a call to harmonic. So it is calling harmonic, which is another method, to which it passes arg as a parameter. Then harmonic does whatever it is supposed to do, return back. Then the value is assigned to the value, it gets displayed out to the screen, and then it goes back and I is now the next value. And like that, the process continues. What happens behind the scene when this is happening? Okay, so for that, you know what? Let me put this on one side and let me start a blank PowerPoint. So we're going to put this on one side of the window and we're going to grab this guy. I'm going to put him on the other side of the window. Okay. Insert table. Okay. When the program runs, the first method to be running in the program's memory is main. That's this guy. When main hits this line, call harmonic, what happens to the main? Main goes down and harmonic comes up. So your pointer is only pointing at this guy, which tells him who is running at the top of the stack. It works like a stack. All memory calls, all method calls work like stacks. So there's always a method at the top of the stack. If that method calls another method, the caller goes down the stack, and the one that you're calling comes up the stack. So harmonic will run all 4 of its lines. When harmonic will be done, harmonic will be thrown out and the main will be moved back at the top. And then your program will start running main because your program only runs the ones that are at the top of the stack. All others are kept in memory waiting their turn. Then main makes another call to harmonic. So what happens? Then main is now pushed back here and harmonic comes back running. If harmonic would have called somebody else, then harmonic would be pushed one step down and that somebody would be running in place of harmonic. This is called the stack. It always runs the item at the top of the stack, and this methodology is called last in, first out. The method that comes in last is the first to get out, and then the method underneath who called it becomes the active method. Does this make sense to you guys?
Somewhat.
Okay, tell me, let me explain that somewhat, and let's turn the word somewhat to yes.
It's very hard to follow the weird path of this loop structure. I don't really know how to describe how I'm confused. It's very hard to follow.
Forget about the loop structure. Do you understand how the calls take place? I don't want you to understand this code. All I wanted you to understand was how one method calls another and what goes behind the scene in memory.
Then yeah, I understand that.
Yeah. Forget about this code, right? So all I want you to understand, and let me know if you have any questions about, is when a method calls another method, what goes behind the scene in the memory is that the caller goes down the stack and the caller is up the stack. The called is up the stack, the caller is down the stack. The called is running and it's at the top of the stack. When it is done, it's thrown out and the caller now resumes the top spot. And your program is only running the top spot guy. And all others are kept in memory. And the reason is when this guy is done, the computer needs to know the next item in line where to resume from. So he not only just remembers the memory, it also remembers what instruction so that it can resume the program from that instruction onwards. Okay, so that's why on page number 147, it says that it maintains a subroutine stack. Each call subroutine command places an entry onto the stack. So anytime a call is made, it puts an entry on the subroutine stack. When each subroutine ends, its entry is removed from the stack. If one subroutines call another subroutine, the depth of the subroutine stack deepens. Do you guys follow these 3-4 lines at the bottom of page 147?
Yeah.
Okay. The default maximum depth of the subroutine stack is 99. What does that mean? You can have a caller calling a called, who is calling a called, who is calling another guy. Like that, you can go deep as 99 calls, which is usually never achieved, especially with a language like CL. If a subroutine command were to cause the subroutine stack depth limits to be exceeded, an error message would be issued. The declare processing option command lets you adjust the depth limit of subroutine stack to any value in the range of 20 to 9,999. So if you think your program will need more than 99 subroutine nested calls, then you can go all the way up through 9,999 calls, where 9,998 could be in a wait state while the last one runs. You code the declare processing option command in the declaration section of the program with the declare and declare file command. The subroutine stack parameter may be coded without a keyword as the first parameter. In addition to setting the subroutine stack depth limit, the declare processing option command lets you specify compiler processing options to control the action of the compiler or the properties of the compiled modular program. These options are many of the same options available with the create CL module,
Yeah.
create bound CL,
Yeah.
and so forth. Okay. Now the declare processing option command is shown to you on page 148. And that shows you that you can have a declare processing option where you can give your subroutine stack. You can give the log if it needs to be logged, and all of those parameters. These parameters must use keyword notations. You can use the declare processing option to store these compiler options in the source member instead of trying to remember the correct options each time you compile the source code. If you have a value returning subroutine, then what you will do is, as it's on page 147, what you can do is you will then write a regular subroutine, and then towards the end, on the very last line, what you will do is you will write the return val. Okay, let me increase the font size here. It's a return val. That means this subroutine will return a value of 0. If you are using a value returning subroutine, then the caller of such a subroutine must have a variable to hold the returning value. So it is slightly different than how you would have it in Java. For example, in Java, we used to have a variable like value equals to harmonic arg. So harmonic will return a value, sum, which will then be assigned to value. We don't do it that way over here. Rather, we declare a variable in the line of the calling towards the end where the incoming value will be held. Similarly, if you want to leave a subroutine before the subroutine reaches the end of its cycle, like here in this example, that's also on page 147, you will say if cancel equals yes, then return subroutine means this is how you exit a subroutine before it reaches the end of the subroutine cycle. Now go ahead and read the chapter summary on pages 148 and 149. Next, I will be putting you guys in a breakout room. Absolutely. You know, to start the fun, we'll begin with the green screen. Come on. It's fun stuff, man. I don't know why you guys don't like green screen.
Green screen is fun.
Yeah.
There you go.
Yes, it is. Absolutely. Here's a very interesting thing I want to tell you guys about. One of the fourth semester students, he has not yet graduated, but will be graduating by the end of this semester. And he already was like received an employment with a corporation in the IBM world. And he was hired to work for a corporation that doesn't work in this environment, like mid-range, but they work in mainframes. But based on his knowledge of mid-range and his knowledge of RPG, his knowledge of CL, even though mainframes use ZOS, they don't use iOS, they don't use CL, they use JCL. But things are very similar between the two environments. Once you learn one, you can pick the other one. He was hired to be trained. They will train him to become a COBOL programmer. I was like, wow. But, you know, his exposure to the IBM world landed him that job. And they know it's hard for them to find COBOL programmers in these times. However, there is a huge demand for COBOL programmers coming forth because a lot of these COBOL programmers will retire in a few years, and COBOL is still being used in industry. And they can't find talent. So they're like, okay, is anybody out there who has at least had exposure to the IBM world? We'll get that person, get them trained, get them board, get them trained, and put them out to work for us. When COBOL initially came out back in 1958, it was never meant to last this long. You know, it's been over 70 years. No, 70 years now. 60, 64 years. They never thought it will last this long, but it did. It's still doing. And a lot of these insurance companies and a lot of these guys who are using mainframes, their apps are in COBOL. No, it's not Java control language, Christian. It is job control language. JOB, job control language. Anyway, so I thought it's a very, very interesting story that I'll share with you guys, that exposure in one can land you a job in another. So do not take this experience lightly, because what you are learning through this experience, you can't learn it anywhere in the US or Canada. At least in the US, we know for sure. There is no other school that teaches it. And that's backed by IBM. So they know what you're learning is so unique. Hey, Canada exists, man. They play ice hockey because they're mostly covered in snow. It's a massive, massive piece of land. Okay. You know, they got diamond, they got natural gas, and then they got petroleum. I don't know what natural resources they got, but yeah, it's okay. Give me a green check when you guys are ready. And we will then get started with our next example here. So far, we have been using SP22 and we came all the way through 08. So our next member that I will create will be SP22 Prague 09.
It's taking my system a minute to load, so.
Yeah, that's why I didn't move to the next screen, because I noticed that I didn't get okay from Jordan and you.
Didn't hear you ask, sorry.
Okay, so I believe everybody gave me okay except for Christian, for whom it's still loading. Is the RDI loading or the V2 cloud loading?
The V2 Cloud, it just loaded, so.
Okay, cool.
The RDI,
And V2
right?
Cloud took forever to load for me too.
Yeah, I loaded mine during the break and I had to reconnect a couple times.
Yeah, same.
So
Mine was a one shot, it just took forever.
as long as you're in, you can open RDI.
So Professor
and-
Saad, I have a question for you. This is really off topic. We have this giant bandwidth bottleneck, which is why the V2 always takes so long. Do you have any ideas as to how they could change it to make it so that we like didn't have such strong lag times or connection issues?
I don't know how their setup is. No idea. It's just, it's a third-party company that we take service from. Okay, now that everybody is in SP22 Prog 09, make sure you guys choose CLLE for your member type and hit finish. I'm pretty sure we didn't talk about the dump CL program command, right?
Right.
So let's do that as our very first program. So we will start our program with PGM, and we ended with end PGM, and we have a return instruction right above that. And this is just the skeleton of the code. And this is where the rest of the program can go. Declaration. Okay. So I've copy pasted the name. Make sure you change the names of the variable. Oh, I think I made a mistake. I should have written start somewhere down below here, not in the declaration. So these are the functions we worked with last time, I believe, or operators, the tcat, the bcat, right? So this stuff, whatever I wrote over here is not new to you, but it's just a revision to what we did last time. I declared a few variables, assigned them some values, and I have some more variables in which I use the cat function, the tcat, the bcat, those, sorry, operators, not functions, operators. And then I am also concatenating dir, which is a static text, a literal string with the first name and the last name. And that's what I'm putting in the full name. And now the command is that I want to teach you guys is the dump CL program. That's the command. That is a driving force behind this whole review. Dump CL program. Dump CL program. So what the dump CL program does, that when you're running your program, after you make a call, the variables go through a change. If you want to make sure that those variables are really changing the values or not, you can dump the CL program. You can check the dump file inside your spool files, and that will have all your variables with their changed values. So if you can see the variables are coming up with the changed values, that means the values are changing. So once everybody is done with this code, you save the changes, and then you can compile the code. Okay, give me a green check when everybody is done compiling this code successfully.
So I'm having an output on the line saying program SP22 prog9 or prog9 in library not found.
Are you trying to call it?
Yeah.
Okay, did you compile it?
Yes.
Are you sure? It was compiled successfully without any errors. Did you check your command log to make sure that you have the line saying the following member added to?
Command log. I don't command. All right, I'm going to compile it again.
Let's see. So you should see a message that say created the following program, created in library so-and-so.
Yeah, it doesn't say that.
What does it say?
Actually, it doesn't say anything at all here.
Okay, that means your program is not getting compiled. Close RDI, reopen RDI. It did that last week. I think, was it this class or a different class? I don't remember.
Yeah, it was this class.
So for those of you who are done compiling it, you can go to the green screen, log into the green screen, and you can call the program. Once the program gets called, you will see no output. And where will you go? To check work spool file. Work spool file. Okay. In the work spool file, so I'm going to write in the chat, the first thing that you do after you compile, you call SP22 prog09, then you type work spool file. And in the work spool file, you will have a special entry. What will be the name of the special entry? QPPGM, which is Q program dump. And this is where you will choose option 5 next to the QPPGM dump. Now, if you scroll down, you can see each of your variables with their values that are assigned to them. So notice full name 1. Full name 1 is where we use cat, and cat preserves the entire length of the variable. The length of the variable was 10. So it had 4 spaces for Abby, followed by 6 spaces for remaining, then H, right? Then had remaining spaces for Cox. And then when we used in full name 2 tcat, so in the full name 2, it put everything next to each other. It truncates the spaces. On the contrary, when we used bcat, that's where it just added 1 space. And then we used bcat again with full name 4. So you get to see that you have deer space Abby space Cox. And notice all of them are size 23. So the rest of them are spaces. And where it says more, that means you page down to see the remaining variables. So that's what basically the program dump does. It lets you see to check to see if your variables are really changing values. It saves you from having to do send program message in all variables. That makes things very long. So this is how you can check to see if variables are really changing the values. Was it Tony was having issue? Is it fixed? Or was it Christian? So who was having the issue?
I was having the issue.
Okay, is it fixed? Is it compiling now?
I
The
just
mic was muted. I apologize.
opened it up, so
I don't have a dump file after compiling.
Do you have line 117 dump CLPGM in your code?
Yeah, and I had spelled it wrong, and then I changed it, and then after that, I ran it, and no errors had come. And I
Right.
still,
The problem is after you changed it, you never recompiled it.
no, I did.
You did recompiled it?
Yeah, it gave me a whole new thing. It gave me a whole new set of job logs and the SP22 prog 09 in my spool file.
Okay. Do a screen share. Let's have a look at it.
I'm gonna have to leave the Zoom and join it on my laptop because I'm not currently
Oh.
on my PC.
Okay, why don't you do that in the meanwhile? Let's see if anybody else needs help.
I'm gonna have to rewrite some of it because it didn't save.
Sure, yeah, I mean, you can see my screen, right?
Yes, I can.
Okay, cool.
Yeah, I got it to work.
Oh, you got to do work? Okay, cool. Christian, let me know when you're caught up and you get to compile. In the
I'm gonna
mean,
go check to see if I can call it right now.
oh, okay, cool. How about the rest of you? Everybody else got it? You compiled it? You were able to check the work spool file?
Some errors.
Devin, you have errors?
Yeah.
Okay, so Did you try checking your code with mine, or are these errors during compile time?
Yeah, after I compiled it.
Okay, did you check my code versus yours line by line?
Yeah, it looks like the exact same. I don't know why it's doing this.
Okay, let's have a look at it then, Devin. Can you share your screen? Just one
So I got it to,
Adjust my windows, just 1 second. Okay. What was somebody saying something?
so I got it to, I called it and I didn't get any messages on the message bar. How do I check to see if they're running? it?
Go to work spool file.
I wrote the steps in the chat. So check the chat. So, okay, so we have a declare variable. FN, LN, MI, full name 1, full name 2. Would not refer to. Okay, so you have a problem on line number 112. You see where you wrote full name 1 on line 112? After the 1, has to be 1 space. The space is missing. And that is for all the lines below that. No, just leave 1 space.
Well, if I put a space, it's gonna delete it, right?
No, I'll show you how to do that. Just click there. Okay, click after 1. Okay, now press the insert key on your keyboard. It will change that block to a, you have an insert key on your keyboard, right? Insert,
Yeah, do I have to like click function or shift?
yeah, however you do it. I don't know how your keyboard looks like, but turning off the insert will turn that to a blinking cursor. Now hit a space bar and do the same on each of the lines. You don't have to keep turning off the insert. Yeah.
So I
And
can just
now-
leave it like this?
And then, yeah, because full name is 1 parameter and the value is the second parameter. So when you put it together, it is an error because the command is like, okay, it thinks everything is 1 parameter.
Okay.
Okay. So now you save the changes and recompile. See, all the errors are gone. So how was I able to figure that out? Because your error message down below was about parentheses. So the error message is a little bit of an indicator to tell you what you should be looking for.
Okay.
Okay, so now go to the green screen tab, which is open within RDI. You have one open, right? And log in. Okay, enter. Okay, call the program.
I don't need parentheses, do I?
Nope. The steps are in the chat. I don't know if you are looking at the chat or not. Do you see that in the chat, Devin?
Yeah, no, I see it.
Okay. No, you're already done with that step. Go to the second step. Okay. Now, in your case, you have all these items sitting there that needs to be deleted. So how about you start pressing 4 under option? just keep typing 44444 all the way till the end of that screen, and then hit enter, and then hit enter again. Okay, repeat the process. Yep, keep repeating it till you clear out the spool file. Maybe some of this stuff is sitting out there forever. Because if your spool file gets overfilled, then it doesn't let you compile any more programs until you clear your spool files. So go ahead, do 4 again, all the way through. Enter. Okay, keep doing it. You still have a lot of items sitting out there. I think you lost the control. Hit the control on the keyboard.
This keeps happening and I press control and it doesn't. give
I
me
think
that.
sometimes when you are not in a box, which takes an input, and you press anything on the keyboard, the system takes the control away from you. So maybe try pressing F3 or F, or yeah, okay. Now press F9. Enter, enter, and now do 4s again. Okay, now go to the very last item and choose option 5. Enter, and now you can see the variables with their values in the last column. So full name 1 through full name 4, they all received values from the other variables, but their outputs are different because we used tcat, bcat, and cat. So full name 1 was a cat, full name 2 was tcat, full name 3 was bcat. So bcat leaves 1 space between the values, tcat leaves no space between the values, and cat just writes everything out by the variable length. So since fn was 10 characters, so just put the first 10 characters, then 1 space for the middle initial, oh, sorry, 10 spaces for the middle initial, my bad. And the remaining is Cox, okay? Now it ran out of space because 10 plus 10 plus 10 would be 30, and the variable was only 23. So if I had more letters than Cox with 3 letters, it would have truncated the rest. So that's how the values are sitting here. Anyway, anybody else or everybody else got it? Oh, Victor. Victor was, do you have it now, Victor, or still have errors?
Yeah, I got it now.
Okay, cool. Okay, guys, so let me share my screen again. And this time we will be saving this example as number 10. In number 10, I will leave only a couple of declarations and delete the rest. And over here as well, I will just leave the last 3 lines and delete the rest. So I'm making some changes in my declaration. You can follow those. I want, in this example, I want to write a program where I use loops. Okay. So I would like to use exit
And just,
variable.
I'm sorry to interrupt you. Just be sure you did a save as, right?
Yes, yes, I did saved as. That's why I have SP22 prog 10 in the list. So I have LGL, which is a logical. It doesn't need the size. And the initial value that I'm assigning to it is false, which is 0. I have a variable count, type integer, and I'm assigning it a value 20. So I'm going to write a program using do until loop which is a post condition loop. So do until, do this process. Oh, it's one word, my bad. Do until, it's one word. Till the exit becomes what? True. And this is end do, okay? So it'll be keep looping as long as exit is false. What do I have to do every time it runs? I got to change the variable CNT by subtracting 3 from it. So remember in CL, whenever you want to change a variable's value, you'd never write something like this, count equals to count minus 3. That is not CL. That's a Java equivalent code for this expression, okay? So if I were to do this in Java, this is how I will do it. So in Java or C#, this is how I will do it. And this is how I do it in CL. Okay. If the value of count is less than 5, I want to again change exit to true, so it will terminate. So once you guys are done writing this code, you will compile it. Once you're done compiling, you will make sure that there are no errors. And after that, you will call the program. And this is where, when I ran this, it told me that the value of counter is 2. And the value of exit is 1. That means I was able to successfully change the exit from false to true. And the value of cint was changed to 2. It is a 0, not an O, Cole. It is a 0. So that's a 0 for false. Okay. And that's 1 for true. Sure, go ahead. I mean, like, look, my screen is shared with you guys. So. Have a look at the code. And if anybody has any errors, see if you can fix it yourself.
Should we try calling it?
Yes, if it compiles successfully, go ahead, call it. After you're done calling it, check the spool file in which you check the dump to see that the variable names have changed. The value for CNT should be 2, and the value for the exit should be 1. So it only reports the ending values at which it terminates. So, is there anybody who's having any errors? Aiden is having errors, okay. Anybody else? Everybody's so quiet. Looks like people are still
I'm still
coding.
trying to run the program.
Yeah, that's what I thought. The quietness is about, oh, I'm still catching up.
No, I'm like calling the program. I just more focused on calling the program than answering. My throat
Yeah,
hurts
that's
too.
what I thought, the silence is that you're busy. And the call procedure is exactly the same as I told you guys in the chat. After you call, you look at the work spool file and you check the QPPG dump, choose option 5 next to it and hit enter. And that's where you will find this data. Check the CNT. It should change to a value of 2. Check the exit. It should change to a value of 1 in single quotes, which means true. I will then explain to you guys how we were able to get that.
Mine did not do that.
Your values are what?
20 and 0.
Okay, so go ahead and check your do until loop to see if you wrote everything correctly.
Oh, I have a line. Delete that line. So, that blank line, white space would be the end of a statement, correct?
This blank line doesn't really makes any difference.
That's weird.
That's
Oh,
what I'm asking
I
you.
see. I put my dump program at the wrong end of the program.
Oh, it should be outside of the loop. After the loop, outside of the loop. You probably put it before the loop, maybe.
Yeah, I did on
Yeah,
accident.
yeah.
So it was returning the values beforehand, right?
Yep, exactly.
Not sweet, but cool. All right, I'm good. Thank you.
Mhm.
When I try calling, it says string beginning call SP22 PR not valid command name.
When you tried calling
the-
it, it said it's an invalid command name.
Yeah, I'm in the green screen, so it's like call SP22 prog 10 when I hit enter.
Go,
It says
go ahead.
string.
Share your
Yeah.
screen, please, Kashi.
Sure.
Oh, do you have a space after the call's second L? I think you forgot to put a space after the L, the second L. Yeah. Okay. And then,
Oh, sorry.
there you go.
All right, thank you.
Mhm. Okay, how about the rest of you? Everybody got this? Anybody still working on it?
I just corrected an error and now I'm working on, I called it. And so now I'm kind of just choosing option 5 for,
Okay, how about it'll be much easier for those of you who get done, can you give me a green check? So that once I get green checks from everybody, then I will explain the code. So if anybody still had any questions, you can ask me after I explain the code.
okay. So then if I wanted to ask like what the value should be, I would do that after you explained it.
I will show you what the value is now, but I'll explain to you how we got those values.
Okay.
So for right now, the values that I have are 2 and 1. So I have 2 for CNT as a value, and I have 1 in single quotes for exit.
Okay.
So Tony, it didn't work for you after you called?
I am getting to just view it right now, so one
Okay,
second.
okay.
So the CNT is supposed to be 2, correct?
Correct.
And the exit 1?
And yep.
Yep, perfect.
Okay, cool. So again, anybody who got the correct output, give me a green check. Cole still working on it? Okay, Cole got it. Okay. Tony, if you're done, can you also give me a green check? And we have Kyle and Victor left.
Yeah, it worked perfect.
Kyle, okay, and Victor, do you have any questions? Oh, Kyle got it. Okay.
Sorry, I just forgot to click the check mark.
Oh, okay. Victor has any questions? Okay, did you get it to run, Victor? Okay, okay, so you can see the out. Yeah, just wanted to make sure that. Now let me explain to you the code here, that how did we get to the values of 2 and false. The starting value for CNT is 20. And the starting value for exit is 0. It's a do until loop. That means the loop keeps looping as long as the condition is false. So since the condition is false, it goes into the body of the loop. Then it changes the value of CNT by subtracting 3 from the value. So what do you think the value becomes now after the first run? It was 20. it will now be 17, right? Now, is 17 less than 5? No. So it goes back and checks to see is the exit still false? Yes. Comes down here and says, okay, now we need to subtract 3 more from 17. So it now becomes 14. Is 14 less than 5? No, goes back. Condition is still false. 14 minus 3 is 11. Is 11 less than 5? No, goes back, makes it 8. Is 8 less than 5? No, goes back, makes it 5. Is 5 less than 5? No, goes back, exit is still false. What is 5 minus 3?
2.
2. So that's how we got 2 for CNT. And now since 2 is less than 5, the variable exit now becomes true. And now when we go back into the loop, exit is not false anymore. So the loop terminates. So when the loop terminates, the value of CNT is 2 and the value of exit is 1. Does that make sense?
Yep, it does.
Anybody has any questions? Christian, you okay now? You said you probably, if you have any questions, you'll ask. You're fine? Understood?
Yeah, I got the same values as well.
Yeah, but did you understand what I just explained?
So yeah, it keeps just subtracting it from 3 from 20, and then until it reaches below 5, it's going to keep iterating. Okay.
Exactly. And then when it reaches below 5, it changes the exit to true, and that's when the loop terminates.
So I did have a question for there's the what is it? It's do until, I think, and then there's another one that's like the
Do
opposite.
while.
Do while.
Do while. Do while keeps looping as long as the condition is true. Do until keeps looping as long as the condition is false.
So is there, what's the difference between, I mean, like, I know that the difference is true and false, but like, does it change the outcome at all?
No, it doesn't.
Okay.
It's just do until is more efficient because it's post condition. It makes one less checks.
Okay. Okay. Got it.
Mhm.
Thank you.
So usually the languages that you guys will learn, like Java and C#, it doesn't has any do until loop equivalent. All the loops in Java and C# keep looping as long as the condition is true, and they terminate when the condition becomes false. Only here in CL, you'll see a loop that is looping while the condition is false, and you also have loops that keep looping when the condition is true. So you have both kind of variations in this language. Okay. Okay, so now, if you look under this week's button, you guys already took the quiz. You have an assignment to work on, which is chapter number 9. And let me delete this file. This is old one. I will, after the class is done, when it's done rendering, I will then, put the link over here somewhere tonight. Sometimes tonight, I will put the link for today's class recording.